This question is so beautifully designed that it will make you fall in love with math for real. Here are given this equation, and we have to solve for x. I know that just by looking at it, most of us will quickly think of expanding the expression without a second thought. And that's not bad, but this is what separates a true math genius from the rest. Here's the key. It's that ability to pause for a moment, take a look, and spot the hidden pattern or shortcut that makes everything simpler. Because if you expand this expression directly, you'll end up with a quartic equation, and solving that becomes really, really hard. So expanding it might not be the most helpful approach here. By the way, take a moment to look at this quartic expression. What do you think? How many values of x do you expect we'll get? Since we have a quartic expression which means degree here is 4, it's natural to assume we'll get 4 values for x. Or do we? Let's find that out. All these numbers are in an arithmetic sequence with a common difference of 2. So what if I try to find the middle part of these numbers kind of mean, or an average of these numbers? So we get 1 plus 3 plus 5 plus 7 divided by 4 or 16 divided by 4, which equals 4. Well, I think we are getting somewhere. Let me substitute a variable y as x plus 4. So what will be the value of x plus 1? Yes, right. We get x plus 1 equals y minus 3. Oh, can you now see where we are heading? X plus 3 will become y minus 1. Then x plus 5 will become y plus 1. And x plus 7 will become y plus 1, 3. We did all of this manipulation just to avoid expanding this big expression, and let us see if we can become successful in it. Substitute these values here to get this equals 9. Now look at these two expressions, and also look at these two expressions together. Do they look familiar? Yes, both of them grouped together will be of the form a minus b times a plus b, which equals a squared minus b squared. So this becomes y squared minus 3 squared. And this one becomes y squared minus 1 squared. So now we have y squared minus 9 times y squared minus 1 equals 9. Now, are you thinking of expanding this again? Hold on, we can simplify it into a nicer form. What's the average of 9 and 1? It's 9 plus 1 divided by 2. That's 10 over 2, which equals 5, right? So let y squared be z plus 5. Therefore, y squared minus 9 becomes z plus 5 minus 9, or simply z minus 4. And b squared minus 1 becomes z plus 5 minus 1, or z plus 4. So this is again of the form a minus b times a plus b, and that becomes z squared minus 4 squared, or z squared minus 16, which equals 9. Thus, z squared equals 16 plus 9, or 25. Therefore, z equals plus or minus 5. Now, when z equals 5, we get y squared equals 5 plus 5, or 10. And thus, y equals plus or minus the square root of 10. When z equals negative 5, we get y squared equals 5 minus 5, or 0. So y equals 0. Now, when u-turn-y equals plus or minus the square root of 10, that gives x equals negative 4 plus or minus the square root of 10. And when u-turn-y equals 0, we get x equals 0 minus 4, or simply negative 4. And that's it. So in the end, we don't actually get 4 solutions, like we might expect from a quartic equation. We get just 3. This just shows how a little creativity can turn a seemingly complex equation into something surprisingly elegant. As always, if you enjoyed this video, please don't forget to like, share, and subscribe to our channel. So, good.